let's try question 18 here. So, read the question carefully. Now, this one's a little funny because in a shot put, the guy that does the shot put, if I was to look at his head from above or something like that, and maybe here's an arm that holds the shot put, and here's his other arm, he kind of rotates around, and then he throws the shot put. So, I'm not a great artist, but if you can imagine, that's the guy, you're looking at the top of his head, that's this big ball, this big iron ball, and he spins around and hurls the thing off. So what we have is a mass of a shot put that's 7 kilograms, and it says that it leaves his hand with a speed of v is going to be 13 meters a second, and that during the time that he was pushing on it, he moved at a distance of 1.7 meters. Okay, so they're saying basically what can we figure out from this information, which is actually a good way to do a physics problem. You get information and then you just figure out what can I figure out with this. So so let's see what we can do. Let's imagine that the shot put, let's say, has only been sped around on, let's say, a horizontal plane. This is another typical sort of physicsy trick, which is we just make everything as simple as possible until we can actually sort of solve a very simple problem. And then, the real world is almost always more complicated, but what to do? We start with the simple, and then we tweak things to try to understand the world that's more complicated. So what I can start with is sort of the kinematics of this problem. I can say that if I accelerated this guy over a distance of 1.7 meters, I have something like a similar problem we had before where this kinematics equation turned out to be kind of useful. I have this relationship between the distance that I accelerate something, the acceleration of the object, its initial speed, and its final speed. Often I call this VI, I guess, right? So in this case, if we think about what do we know and what can we figure out, well, we're claiming that we know the 1.7 meters. We're claiming that we know how fast you go, and so therefore I could solve for A, where this VI, we imagine, is you begin by it's not moving, right? So I can solve for the A, and I can get A to be V squared over 2D, minus sign there. Now, it looks like since I know V and I know D, I can calculate that A. Now, if I know that A, that's important because F net equals MA. And so if I know A and I know M and I do know M, I can calculate F net. So now I can say F net is going to be minus M times V squared over 2D. Okay, so all I'm doing is combining this with this, right? Now, in the problem, actually, they're saying, what can we figure out? So, all right, well, what have we done? So we think we've have the opportunity to figure out an A, an acceleration, and we think we have an opportunity to figure out an F net. And if I wanted to think of F net as, let's say, just his hand pushing, then essentially I get an idea of how hard he was pushing on the shot put. Is there anything else we can figure out? I think that's the main thing that we can determine. So the force of hand, so force of hand on the shot put, the force of the hand on the shot put is really we think of it as the main force that's responsible for F net in this case, and we can then say that that's 7 kilograms times the V squared. The V squared in this problem is 13 meters per second, so I can do 13 meters per second, square it, divide by 2 times the distance that he moved around. That was 1.7 meters. 1.7 meters, and this is going to give me a kilogram meters per second squared, which is a Newton, so it's going to give me an answer in Newtons. And here again, it's, whoopsie, this is something that you would normally just do on your calculator. Again, it's a bit of a pain for me to grab a calculator right now, so if I were to just do this roughly in my head, 13 squared is 169. 169 is almost 170. 170 divided by 1.7 is about 100. So this entire piece over here I can turn into about 100. 100 times 7 is 700. 702 is 350. So it gives me 350 newtons. And of course you can just do that on your own on your calculator. And now I would say the last part of this is to try to relate this force to something that I know. And I know that 350 newtons is equivalent to a weight of about 35 kilos. And so, you know, that's a fairly decent force that it looks like the shot putter is exerting during the whole time that he is spinning around over here. Okay, I think that's about all I could figure out, at least quickly anyway. All right, review that, see if you understood what was going on. There were a lot of assumptions, by the way. A lot of assumptions just to make this doable. So if you think like, wait a minute, he kind of went over that kind of quickly, and I'm not sure I should believe all of that, then actually you're probably thinking in like a good physicist. Anyway, see if you can identify the things that I was sort of went over quickly in a somewhat sloppy way.